Go.
Alright, what up guys? My name is Alex Berry and it is June 20th, 2012. I'm doing my third interactive video. I'm going to be working on integration of fundamental rules of calculus and also use substitution. So we gotta do this quickly because there's stuff that we gotta do. So we gotta do this pretty quickly. Our first problem of the integral from -7 to 0 of x cubed multiplied by 1 plus x to the 4th all raised to the 5th power. And of course you have our ds at the end. So normally this would be a really hard problem, but for us it's easy. This is going to be easy because we're just going to use substitution. So we already know this is just practice, so I'm going to go through this quickly. We're going to say this 1 plus x to the 4th equal to u. Now we need to take the derivative, right? So our du is going to be equal to 4x cubed. Now we notice, 4x cubed ds. Now we notice that there's a dx in our problem and an x cubed, but there's no 4x cubed. So we have to make sure that we can substitute completely. So we're going to go and divide both sides by 4, which gives us du over 4 equals x cubed ds. Now it's a simple matter of substituting back into our original function. Okay. So what did 1 plus x to the 4th equal? It equaled u. So now our new integral is going to look like this. The integral, and remember that x to the 3rd, that's just, it changed from x to the 3rd dx, it's changing to du over 4. So we can write that as 1/4 right here. And our u, remember, is 1 plus x to the 4th. So u to the 5th du. Okay? So now we have that. We can move this 1/4 out the way. 1/4 u to the 5th du. Now we just go use our basic integration rules. That gives us 1 to the 6 divided by 6. And remember, times out 1/4 equals, and we didn't set new bounds here, so we can go ahead and put that plus c, right, because we didn't actually establish new u bounds. So that gives us, and we're just going to go ahead and substitute back in for u to save some time. So that gives us 1 plus x to the 4th, 6, all over 24. But remember, when we come back to x's, we have bounds for our x's. So we actually can go and evaluate this integral. -7 to 0. Right? This will be really, really easy because if we put 0 into this equation, that gives us, put 0 in everywhere you see x, that gives us 1 over 24. When you put -7 in here, it's not quite as cool though. So that's going to be 1 over 24 minus, and we have to kind of look at this work over here because it gets pretty darn complicated. Okay, so that's going to be minus 1 plus 7 to the 4th, all raised to the 6, divided by 24, like that. So now we need to figure out what x to the 4th is. So we're going to pause, get out our handy dandy math tool, because some people can't do that in their head. So
Noob.
1 plus, shut up Alan, at 7 raised to the 4th equals 2,402. So then we're going to go and raise our answer to the 6th power. Our answer is now something terrible. Thank you very much, Alan. And then if you notice, we have the same denominator both here and here. So we can actually combine this expression as one thing. So we can combine our fractions like that. It's now 1 minus our answer. And then we go and divide that by 24, which gives us our answer. We're just going to put this in scientific notation because this is a terrible problem. And it's not chemistry, so no rounding. So that's all going to be times 10 to the 18th. Alright, and that's our first problem.
Woo! I'm too tired to celebrate.
Alright, so that's the first problem. So we got that. You see how we went through the steps? If you have any other questions, I need you to go and just review the video because it's all in there. Just go slow, take it slow.
Or go to alexberrymathteacher.com.
Alright, here we go. Alex Berry again here for part 2 of our interactive learning video. Now we're using one of the fundamental rules of calculus. Okay, so what happens if we take the derivative of an integral? Alright, this is where it gets kind of tricky. I need you to follow me step by step. So, here's our problem. We're going to write it on the board. I heard you, Alan. Okay, stop it. So, we're going to write this problem on the board. dx. Remember, this is our derivative notation. And then our integral notation looks like this. So, from 0 to x, root 1 plus 5t dt. So I know right now you're kind of lost. How in the world can we integrate in respect to x and take the derivative in respect to x when we're working with t's? What can we do? Well, I have good news for you guys. There's a rule for this though. You don't have to know why it works, you just memorize this crap. So let's look up here at our basic formula. When you take the derivative of an integral for any bounds for something in terms of one variable, to solve it, all you do, the derivative and the integral cancel each other out, but b of x will actually go into here, and remember b is just like another constant. So it's where x is your variable, b is just going to be whatever constant the problem assigns you. So this b of x is going to go into your function, and then you're just going to do times this by the derivative of whatever this is. So the derivative of b of x, which we have just denoted as dx. Alright, we got that? Good. Now let's solve these two problems. Let's knock them out. Alright, so again, what we said here, this is like our b of x. So coming back up here. So to solve this problem, all we do is that we literally put x in for t. I'm sorry, I can draw that a little better. We put x in for t, which gives us root 1 plus 5x. And then we substitute this in. Sorry, this kind of substitutes in and becomes dx. But when we think about it, what's the derivative of x? The derivative of x is just 1, so that's like saying 1 times this function, which just equals root 1 plus 5x. And that's your answer. See, it's that simple. If you were lost, that's cool because we have one more problem coming up. Let's get our piece of paper, our trusty eraser. No. Like really, does anyone have an eraser? Like, come on. The demo pad is sliced out right here. Alright, our next problem, it's almost easier. I know, right? I know. So our next problem looks like this. The derivative of an integral sine to the 2t dt.
That's an x that you wrote. That looks like an x next to the 2.
My fault.
There you go.
My cameraman's a little picky right now. We're going to integrate that from 0 to 3x. I know some of y'all look at me like, okay, y'all are tripping. Now you got sine in there, y'all are tripping. But trust me, this is cool. We're going to use the same thing that we used up here. Let me rewrite this since I kind of erased it. Remember what we learned last time? How the derivative of an integral basically just cancels it. You with me, cameraman?
Well, I mean, I got you, yeah.
I'm joking. So again, we're using the same formula. So the derivative is going to cancel out our integral. It's just like if you multiplied something and then divided by something, it cancels it out, right? So that gives us sine 3x comes in for t, so this 3x comes here. So that equals sine 6x. Okay, but then remember, we have to do the derivative of this thing. So if our function, we could say equals 3x, then the derivative of that function just equals 3, right? And if you remember here, we times our function with our new value in it. We times that by its derivative. So coming out here, the derivative of 3x is going to come out in front like this. And that's our answer. Stop.